Okay, today is Unit 6, Day 5, and this is, we're going to talk about rational exponents, Part 1. Now, the word rational, it often gets forgotten what rational means. All rational means is that it can be written as a fraction, so something, some number, say n over m, or say two letters, so n and m can be any number. If it can be written as a fraction, it's fractional, or it's rational. So our learning target is I can write and simplify radical expressions with rational exponents. We're going to, instead of having like x to the fifth, we might have x to the 5 halves or something like that. So how can we do that? So let's brainstorm or remember, how can we solve this without using a factor tree? So the quick way of simplifying this, we want to find how many groups of 4 were in 80. So the fast way of doing that was take 80 divided by 4. So this would be the same thing as 80 divided by 4. And then 80 divided by 4 is actually 20. So you can just write down 20, which that ended up being a nice, neat whole number because you could divide it, get a whole number, and that's fine. Sometimes it doesn't. So then when that happens, we can write it as a fractional, a fraction rational exponent. Okay, so let's quickly do these guys. If I want to say simplify this, you'd say x to the 93 thirds because you could divide it by 3, which would be the same thing as 31. And that is rational. It is written as a fraction. It's just over 1. So we haven't really gotten to the real difficult ones yet. 200 divided by 5, that would be x to the 40th. This guy here, it's kind of different, but that's a 2. When it's a square root, it's not written, it's a 2. So this would be x to the 51 divided by 2. And instead of leave it in radical form, in this one we'd say, well, there's 25 would come out. And we might have x to the 25th radical x. That's radical form. We're going to leave it with a rational exponent instead. We can actually do a little bit more work with it. We can do more combining and other operations if we leave it as a rational exponent instead. So instead of doing this now, we'll leave it here like this for these kind of problems. It doesn't mean forget how to do this. You don't want to forget how to do this. There'll still be questions on this. If we say put the answer in radical form, that's the answer. But we're doing rational exponents. This guy here, nothing's written, but this is actually a first power and this is actually a second root. So that'd be 1/2. So anytime you see x to the 1/2 power, that's the same thing as square rooting it. Just as a side note, if I said 9 to the 1/2 power, what would that equal? That's the same thing as the square root of 9, which is 3. If you type that in the calculator, take 9, raise it to the 1/2 power, you'll get 3. So the rational exponent notation here is, and I should mention, it doesn't matter if a is inside the radical or not. I'll just quickly say that this could be the same thing as the bth root of x raised to the 8th power. They both, either way, they both can be simplified to x to the, and this is on top, that's on bottom, a over b power. So no matter whether the a is inside the radical or outside the radical, either way you look at it, this is true. Okay. So if you want to, you could pause it right now. Pause the video and try these out. See how well you know what you're doing. Otherwise, you can kind of go with me here. So this would be the same thing as x to the 2 goes on top over 3. The root always goes on bottom. The root always goes on bottom here. So this would be y to the 9 is the exponent, the 5 is the root. So y to the 9/5 power. Here's 11 to the, now this is a 1, even though it's not written, so it would be a 1/4 power. So you're taking the 4th root to the 1/4 power. That 2 is not written, and the 1's not written, the exponent and the root, neither one's written. Well, if neither one are written, then it's a square root, so it's a 1/2. Here I've got x to the, and I should mention, even though there's two things going on under here, I can do them separately. This would be x to the 2/4 power. This would be y to the 5/4 power. One of these I could simplify, so 2/4, that'd be the same thing as x to the 1/2 and y to the 5/4. And then over here, so if you took 4 cubed and then took the cube root of that, some of you probably know, well, those just cancel each other out, so that's just 4. Well, let's say we didn't notice that. Let's just say, well, I'm going to stick to what we just learned. We said 4 to the exponent over root. Well, 3 over 3 is 1. 4 to the first power is 4, so I still get 4 either way you look at it. So whether you remember that or not, you get 4. Okay, so flip this guy over. And let's go the opposite direction. So let's say I give it to you in rational exponent form, which all of these are in rational exponent form, and I want you to write it in a simplified radical form, or simplified radical expression, which means I want a radical in there. So this one here, remember, the exponent goes on top, the root goes on bottom. So this is the 7th root, almost messed myself up there, the 7th root of, you can put 6 on the outside or 6 on the inside or outside, doesn't matter. I'm going to just put it on the inside. But you could have the 7th root of y all raised to the 6th power and that'd still be true. This one here, bottom number is the root, top number is the exponent. Okay? This guy here, exponent, and then roots 2, I can leave it blank or I can put a 2 there. It's totally up to me. It doesn't really matter. This guy here, the whole thing is being taken to the 1/3 power, so the whole thing is under the radical. So I got a 5 and a b under there. It's all to the first power, so I can just leave them as they are, but then the cube root, the 3 on bottom means cube root. Whereas this guy, the 5 is not being taken to the 1/3 power. So the 5 is still 5. The b goes under the root. It's a cube root, and it's the first power, so I can leave it like that. Let's see. Now, letter B. Oh, and I should mention here, you could simplify. I'm just looking at these guys here. This guy here, there's actually 2 being multiplied by itself 4 times, and for every 3 you could pull 1 out. You could simplify that to 2 on the outside and then the cube root of 2 on the inside. So I guess I went a little faster. If this is ever more than 1, that means something's going to come out. Okay, so all the rest of these, like this guy here, same thing. I could actually take an x to the cube, or x cubed on the outside, radical x, would be the simplified version of it in radical form. So I should have finished those. I kind of got a little sloppy there. I didn't finish simplifying them, but if the exponent's more than 1, something's going to come out. If it's less than 1, nothing's going to come out. So that's kind of a way of looking ahead. Hopefully you remember. If not, if you have a negative exponent, you can rewrite it as a positive exponent on bottom. That can go the other way too. I could have 1 over a to the negative x. That'd be the same thing. I could bring it up to the top as an a to the x. You could do it that way too. So both of these are true. If it moves from top to bottom, the sign on the exponent changes. So simplify without using a calculator and then write in reduced radical form. Okay, so this guy here, if I'm taking the 1/4 power, that's a 4th root of 625, and now simplify. So 625 is the same thing as 25 times 25, that's 5, 5, 5, 5. There actually is 4 of them right there, so it turns out 625 has a 4th root and it's 5. So this equals 5. Now you can check yourself with a calculator, that's fine. I don't mind if you check yourself, but you do need to be able to do this without a calculator. Like on the quiz, I'm going to be looking, is this work there? If the work's not there, it's no credit. Okay, I need to see that so I know you didn't just put it in the calculator. 27, this is going to be the cube root of 27 squared. Now you have options. You can square it first or you can cube root it first. It doesn't matter. It's up to you. If one of them is easier, do them first. Now, would it be easier to square 27 or would it be easier to cube root 27? Well, 27 is 3 times 3 times 3, so I have a cube root. The cube root of 27 is going to be 3, and I haven't squared yet, so the squared is still hanging out there, so that equals 9. So look at which one's easier. Okay, which one's going to be easier to do. I guess another way you could look at this too, I could rewrite this as 27 times 27 and consider that the first 2 branches of your factor tree. This would be 3 times 9, 3 times 9, 3, 3, 3, and 3, and then here's a group of 3, here's a group of 3, pull 2 3s out, you get 9. So I guess whichever way you really want to do it is fine. Probably a little bit faster here, just think, well, I can cube root that pretty easy, get 3, and then 3 squared is 9. This one here is the square root of 4 cubed. Now, would you rather cube 4 first or square root it first? Well, It's going to be easier to square root. A lot of times the root's going to be easier to do first. The square root of 4 is 2. I haven't taken it to the third power yet, so I still got to take it to the third power. That's 8. Let's see, 32. I would much rather take the fifth root of 32 because that seems like it's probably 2. So 2 times 2 times 2 times 2 times 2 is 32. So that would be 2, and then I haven't done the fourth power yet. Now multiply it back out. 2 times 2 times 2 times 2 is 16. So most of the time the root's going to be easier first to do the root. Now the negative 16 here, that negative is technically not part of the, the exponent's not being taken to, let me say that right, the negative is not part of the base that's being raised to the power. All this means is my final answer is going to be negative. It'd be much different if it was this. If it was written with parentheses, that means I would write like this. I'd be taking the square root of negative 16, which you cannot do. That wouldn't be possible. This is saying take the opposite of the square root of 16. The square root of 16 is 4, so this would be the opposite of 4. So be careful where the negative is. If the negative is out front with no parentheses, that means it's not under the radical. If it's in parentheses, it's in the radical. So it's be negative 27 inside of a radical, cube root, fourth power. It's got to be easier to take the cube root first. Cube root of negative 27 is negative 3. That is still in parentheses. That is a parenthesis thing. We're doing the whole thing. So now we're doing negative 3 to the fourth power, and that's going to be 81. At any point, if you just want to pause and try them out, go for it. If you don't feel so confident with it, keep listening and keep working with me, but definitely quiz yourself a little bit here. See if you know what you're doing. So maybe pause the video, do the rest of them, then you can just kind of fast forward and check your answers. Save yourself some time. This guy here, a negative exponent, that's the same thing as 1 over 36 to the positive 1/2. Doesn't mean the answer is negative. It means that it's going to be a fractional answer instead of a big number answer. So this would be the same thing as 1 over 2 is the root, 1's the exponent. So the square root of 36 is 6, so 1/6. 27, fifth power, third root. Do the root first. That's 3. 3 to the fifth, 243. And I know those because I'm a math teacher. Just put them in the calculator. If you're doing 3 to the fifth, that's fine if you use a calculator for that. I don't want you to just type this in the calculator and give me 243. If I'm looking at a quiz and you say this equals 1/4 and that's your work, I'm not taking that. I need to see your work. Because what I should see is that negative exponent means 1 over 8 to the 2/3, which equals 1 over the cube root of 8 squared. And it's probably easier to do the root first. So the cube root of 8 would be 2. So this would be 1 over 2 squared, which is 1/4. So that's what I should see. That's what I'm looking for on the quizzes. I want to see that work so I know you know what you're doing. When they give you a decimal exponent, make it rational. Make it a fraction. This is 1.2, which is 1 2/10. So negative 1 2/10. Make it improper, so it's be negative 12/10. And then I can reduce that too. You can always reduce the exponent. So that would be negative 6/5. So I'm going to take negative 32 to the negative 6/5, which means the negative means it's going to be 1 over. So it's going to be 1 over negative 32 to the positive 6/5, which equals 1 over, this is negative 32, the fifth root. So the fifth root of negative 32. Now earlier we did the fifth root of 32. Where was it at? I know we did it. Yeah, right here. Yeah, we did the fifth root of 32 is 2. Down here, the fifth root of 32 is 2, but it's a negative because we have a negative 32. So this is going to be 1 over negative 2 to the 6th power. That's still in parentheses. We have a negative to an even power. It's going to be positive. This is going to be 1 over 64. So 1/64. Let's see, next guy. Again, negative 1/2 would be the same thing as negative 3/2. So I got 9 to the negative 3/2. And make it a fraction. Negative means to be 1 over 9 to the positive 3/2. And now write it as a radical. I'm going to write it over here now. So this would be 1 over square root of 9 cubed. Because the 2 is the root, the 3 is the exponent, the square root of 9 is 3, so it'll be 1 over 3 cubed. Since there's no negative, I'm not going to put parentheses there, so 1 over 27. Okay. And then the last guy here, 0.5 would be the same thing as 1/2, so I got negative 49 to the 1/2 power. That's the same thing as, again, since it's parentheses, the negative goes under the radical, square root of 49, negative 49 to the first. Well, you can't have a negative even root, because if it's a square root, nothing times itself equals negative. So this one is, there's no real answer, no real root. I could do some imaginary stuff. Don't worry about that right now. We're just going to leave that as just there's not an answer, not a real answer for that one, not a real real number. There's an imaginary number, but not a real number.